Practical Geometry Assignment. Introduction to Practical Geometry. This module will give an introduction of practical geometry. Practical geometry is used in drawing various shapes and figures that help us in constructing technical drawings and charts. Let us first study the instrument that helps us in constructing various shapes. 1. Ruler. It is a scale that is used to measure the length of a straight line and distances. 2. Compasses. An instrument with two arms, one sharp and one with a pencil, that can be used to draw circles or arcs. 3. Divider. It consists of a pair of pointers that is used to measure the arc or lengths. 4. Set square. It is a right-angled triangle that is used to draw lines that are perpendicular. 5. Protractor. It is a semicircular instrument that has marking along the circular ends. It is used to measure and draw angles. Let us draw a circle whose radius is given. Step 1. Draw a line segment of the given radius. Name it PQ. Step 2. Place the pointer of the compasses at P and open it for the required radius PQ. Step 3. Now turn the compasses slowly to get the required circle. We get a circle with center P and radius PQ. Example: draw a circle of diameter equal to 8 cm. Explanation: we first find the radius of the circle. We know that the radius is half of the diameter of the circle. So, the radius is equal to half of 8 cm, which is equal to 4 cm. Now, let us draw the circle. Step 1. Draw a line segment of length 4 cm. Name it PQ. Step 2. Place the pointer of the compasses at P and open it for the required radius PQ. Step 3. Now turn the compasses slowly to get the required circle. Example: draw concentric circles of radii 3 cm and 5 cm. Also, mark a point K that lies in the exterior of smaller circle but interior of bigger circle. Explanation: concentric circles are the circles that have same center but different radii. We first draw a circle of radius 3 cm from a point O. We follow the steps as shown here. We first make a line segment of 3 cm. Mark one end of it as O. Open the compasses for 3 cm and keep the pointed end on O and turn around the compasses to draw the circle. We now take O as center and draw another circle of radius 5 cm. For this, we open the ends of the compasses for 5 cm. Then we keep the compasses pointer end at O and slowly turn around the compasses to get the second circle. Thus, we get the required concentric circle. Now, mark the point K anywhere outside the boundary of inner circle but inside the boundary of outer circle.
Circle. We see at various places the shape of a circle in our daily life. Clocks are good examples of circle. A 1 rupee coin, wheel and tires are some examples of circles. Take a bangle and place it on a sheet of paper and starting from a point, move the pencil along its curved edge. We get a closed curve and this closed round curve is called the circle. Take a thread and place it along the edge of the circle, starting at a point and ending at the same point. Now, measure the length of this thread. This length is called the circumference of the circle. Take a compass with a pencil slid on it. Draw a circle with the length between the sharp point of the compass and the pencil as 5 cm. We get a perfect circle as shown on the screen. So, we can say that circle is a closed path which is always at a fixed distance from a fixed point. The fixed point O is called the center. The fixed distance is called the radius of the circle. Let us now understand the various terms related to circle. This is a circle with center O. Consider a point P on the circle. Join O and P. The line segment OP is called the radius of the circle. We can draw countless number of radii on a circle. Take one more point R on the circle. Draw a line segment PR passing through O. This line segment is called the diameter of the circle. We can draw countless number of diameters on a circle. Consider a point Q on the circle. Draw a line segment PQ. This line segment is called the chord of the circle. A line segment joining any two points on the circle is called the chord of a circle. These are all chords of this circle. We can draw countless number of diameters on a circle. And we see that the diameter of a circle is also a chord of the circle. The diameter is the longest chord of the circle. Remember these important points. Diameter of a circle is also a chord of the circle. The diameter is the longest chord of the circle. We can draw countless number of radii, diameter and chords in a circle. Look at this circle. We can see that AB is a chord. AB divides the circle into two parts. Each part is called the arc of the circle. An arc is the portion of the boundary of the circle. This is the minor arc and this is the major arc. Symbolically, we represent the arc AB like this. When we draw the longest chord on this circle, we see that it divides the circle in two equal parts. Each part is called a semicircle. Circle with different radii and same center is called concentric circles. A region in the interior of a circle enclosed by an arc on one side and a pair of radii on the other two sides is called a sector of circle. A pie-shaped part of a circle is called the sector. A region in the interior of a circle enclosed by an arc and a chord is called the segment of a circle. The yellow part and the pink part both are the segments of the circle. The yellow part is the minor segment as it is made up of minor arc or the shorter arc and the chord, whereas the pink part is called the major segment as it is made up of major arc or bigger arc and the chord. So, a chord divides a circle into two parts, minor segment and major segment. A major segment is formed by the major arc and the chord, whereas a minor segment is formed by a minor arc and the chord. What if this chord passes through the center of the circle? We know that when a chord passes through the center of the circle, then it is called as the diameter of the circle. And a diameter divides a circle into two equal halves. Each half is called as semicircle. Let us consider a line outside a circle. Now, when we move this line slowly toward the circle and stop here, we see that the line touches the circle at just one point. In such a situation, this line is called as the tangent to the circle. If we name the circle and line like this, we say that the line L is tangent to the circle with center O. Now, let us move the line further toward right and stop here. We see that the line cuts the circle in 2 points. So, this line is called as a second to the circle. The line L is cutting the circle in A and B. A second is a line that intersects the circle in 2 points.
Line segment. This module will explain the construction of the line segment. A line segment is a part of line that has fixed length and two endpoints. For example, AB is a line, but PQ is a line segment as shown here. Let us now learn how to construct a line segment using compasses and ruler. Let us draw a line segment whose length is given as P units. Step 1. Mark any point P on the plane. Step 2. From P, draw a straight line L of any length using a ruler. Step 3. Place the pointer on the 0 mark of the ruler and open the pencil end of compasses for the given length P units. Step 4. Without changing the opening of the compasses, place the pointer on P and mark an arc on L. Name that point Q. Thus, PQ is the required line segment. Example, draw a line segment of 5.2 cm. Explanation. Step 1. Mark any point P on the plane. Step 2. From P, draw a straight line L of any length using a ruler. Step 3. Place the pointer on the 0 mark of the ruler and open the pencil end of compasses for the 5.2 cm. Step 4. Without changing the opening of the compasses, place the pointer on P and mark an arc on L. Name that point Q. Thus, PQ is the required line segment. Let us now learn to construct copy of a given line segment using compasses and ruler. Example, draw a line segment AB of any length. Construct another line segment PQ such that it is thrice of AB. Explanation. Step 1. Fix the compasses pointer on A and the pencil end on B. Step 2. Draw any line L. Choose a point P on L. Without changing the compasses setting, place the pointer on P. Step 3. Mark an arc that cuts L at a point, say S. Now, PS is a copy of AB. Now, place the compasses pointer on S and mark an arc on L at T. Now, place the compasses pointer on T and mark an arc on L at R. PR is the required line segment. Perpendicular bisector. This module will explain the construction of perpendicular bisector. The perpendicular bisector of a line segment is a line that makes right angle at the midpoint of the given line segment. Consider a line AB. If PQ is the perpendicular bisector, the AP is equal to BP and angle QPA is right angle. Let us learn the steps of constructing the perpendicular bisector of a given line segment. Step 1. Draw a line segment AB of any length. Step 2. Place one end of the compasses at A and open the length with more than half the length of AB. With A as center, draw an arc on both sides of AB. Step 3. With the same radius and with B as center, draw another arc using compasses. Let it cut the previous arcs at C and D. Step 4. Join CD. Thus, CD is the required perpendicular bisector of AB. Example, draw a line segment of length 8 cm. Divide the line segment in 4 equal parts. Explanation. Step 1. We first draw a line segment AB of 8 cm. Step 2. Then we place one end of the compasses at A and open the length with more than half the length of AB. With A as center, draw an arc on both sides of AB. Step 3. With the same radius and with B as center, Draw another arc using compasses. It cuts the previous arcs at P and Q. Step 4. Join PQ. It meets at AB on point C. Now, we again divide AC and BC following the same steps. Construction of perpendicular. This module will explain construction of a perpendicular. Any two line segments that are inclined at right angles are called perpendiculars. Observe the corner of a room. There are three lines that meet each other at that point. All the three lines are perpendicular to each other. Similarly, observe the corner of a rectangular sheet of paper A, B, C, D. AB and BC make an angle of 90 degrees. Hence, AB and CD are perpendicular. Let us learn to draw a perpendicular to a line through a point on it. There are two ways of drawing a perpendicular at a given point. 1. Using ruler and set square. 2. Using ruler and compasses. Let us learn the first method for making a perpendicular. Step 1. Draw a line of any length. Mark a point P where perpendicular is to be drawn. Step 2. Take a ruler. Keep it along the line drawn. Step 3. Without moving the ruler, place the set square on point P. Hold it firmly. Step 4. Draw a line along the edge of the set square that passes through P. Thus, we get the required perpendicular. Let us now learn the second method of drawing a perpendicular. Step 1. Draw a line of any length. Mark a point P where perpendicular is to be drawn. Step 2. With P as center, draw a semicircle of any radius. Let it intersect the line drawn at M and N. Step 3. With M as center and a radius more than MP, construct an arc. Similarly, with N as center and a radius more than NP, construct an arc that cuts the previous arc at Q. Step 4. Join PQ. Thus, PQ is the required perpendicular. Let us now learn to draw a perpendicular to a line from a point that is not on it. There are two methods for doing it. 1. Using ruler and set square. 2. Using ruler and compasses. Let us learn the first method. Step 1. Let L be the given line and P be a point outside L. Step 2. Place a set square on L such that one arm of its right angle aligns along L. Step 3. Place a ruler along the hypotenuse side of the set square. Step 4. Hold the set square firmly. Slide the set square along the ruler till the point P touches the other arm of the set square. Step 5. Join PQ along the edge through P, meeting L at Q. Thus, PQ is the required perpendicular. Let us now use the second method to draw the line segment. Step 1. Draw a line L. Step 2. Mark a point P outside L. Step 3. From P, construct an arc that intersects the line in at least two locations. Step 4. Name the 2 points of intersection where the arc crosses the line as A and B. Step 5. From A and B, construct 2 other arcs that intersect at a point immediately below the line. Let the point intersection be Q. Step 6. Join PQ. PQ is the required perpendicular of line L.
So just you are supposed to just draw a chord. I am joining these 2 points of circle and I have got this chord. So draw a chord. You can draw any chord. You can also draw a chord somewhere here in this circle. Okay, but I am drawing here. The third step is that draw a perpendicular bisector of the chord of the circle. Now I am supposed to draw a perpendicular bisector of this line segment, which is the chord of this circle. If you don't know how perpendicular bisector is found, so I am giving my another video on perpendicular bisector. So you are supposed to pause this video right here and watch my this video. Okay, so now let's draw the perpendicular bisector of this line. So I'm taking a compass for drawing a circles. So first circle that we need to draw, taking first point of this line segment as a center, and we are supposed to draw a circle with a radius which is more than the half of this line. So this is approximately more than the half, so I can draw a circle. Since in the video of perpendicular bisector we have shown that we just need a point of intersection, so instead of drawing the whole circle like this, instead of drawing this whole circle like this, I am not drawing the whole circle. I am just taking arcs. One arc right here and another arc right here. Okay, I have taken 2 arcs. Similarly, now I would take the second point of the line segment which I am bisecting as a center and with the same radius. Now I cannot change the radius of the circle. I cannot change the radius of this compass, and taking another arc which intersect this arc and taking one arc right here which intersect this previous arc. Okay, now I have drawn the arcs. Now I am just supposed to join these 2 points of intersection to draw a perpendicular bisector. Again, I am saying that if you don't know how to draw a perpendicular bisector, so please watch my video on that. The video link is in the description of this video. So I have matched these 2 points. I have drawn a line segment by joining these 2 points of intersection, and here I have got the perpendicular bisector of this line, which is actually the chord of this.
Construction of angles. This module will explain construction of angles. When 2 rays meet each other at a point, they form angles. Let us learn to make angles using a protractor. Suppose we want to construct 72 degrees. Step 1. Draw a ray OA with endpoint O. Step 2. Keep the protractor along OA such that center point of the protractor is on O. Step 3. See the 0 mark that lies on the ray OA. Count 72 degrees from there and mark a point B. Step 4. Join OB. Thus, angle AOB is 72 degrees. Let us now learn to draw a copy of an angle. Step 1. We are given an angle of certain measure. To draw its copy, we first draw a line M and choose a point P on it. Step 2. Now place the compass's end at the vertex of the given angle and draw an arc, cutting both the rays at A and B respectively. Step 3. Use the same compass's setting to draw arc. Use the same compass's setting to draw an arc with P as center, cutting M in Q. Step 4. Now keep the compass's end at A and open it till B. Step 5. Place the compass's pointer at Q and draw the arc to cut the arc drawn earlier in R. Step 6. Join P, R. Thus, angle P is the required angle. Example. Draw an angle of 120 degrees. Explanation. Step 1. Draw a ray OA with end point O. Step 2. Keep the protractor along OA such that center point of the protractor is on O. Step 3. See the 0 mark that lies on the ray OA. Count 120 degrees from there and mark a point B. Step 4. Join OB. Thus, angle AOB is 120 degrees. Construction of angles by sector and different angles. This module will explain construction of angles by sector and different angles. Angle bisector is the line that divides an angle in two equal parts. Let us learn the steps to construct angle bisector of a given angle. Let us draw angle bisector of a given angle AOB. Step 1. With O as center, draw a semicircle that cuts both the rays of the angle AOB at C and D respectively. Step 2. With C as center and radius more than half CD, draw an arc in the interior of the angle. Step 3. With same radius and D as center, draw an arc in the interior of the angle that cuts the previous arc at M. Then, OM is the required angle bisector. Let us now learn to draw some angles of specific measure. 1. 60 degree. Step 1. Draw a line L of any measure. Step 2. Mark a point O on it. Step 3. With O as center, draw a semicircle of any radius. Let the semicircle cut the line at A. Step 4. With A as center and same radius, draw an arc that cuts the semicircle. Let it cut at B. Step 4. Join OB. Angle AOB is the required angle. 2. 120 degree. Step 1. Draw a line L of any measure. Step 2. Mark a point O on it. Step 3. With O as center, draw a semicircle of any radius. Let the semicircle cut the line at A. Step 4. With O as center and same radius, draw an arc that cuts the semicircle. Let it cut at B. Step 5. With B as center and same radius again, cut the semicircle at point C. Step 6. Join OC. Angle AOC is the required angle. Example. Draw an angle of 150 degrees. Explanation. To draw an angle of 150 degrees, we first construct 120 degrees angle and bisect the angle between 120 and 18 degrees to get 150 degrees. Let us see the steps of construction. Step 1. Draw a line L of any measure. Step 2. Mark a point O on it. Step 3. With O as center, draw a semicircle of any radius. Let the semicircle cut the line at A and D respectively. Step 4. With A as center and same radius, draw an arc that cuts the semicircle. Let it cut at B. Step 5. With B as center and same radius, again cut the semicircle at point C. Step 6. Join OC. This gives us 120 degrees. Step 7. With C as center and radius that is more than half CD, draw an arc in interior of angle DOC. Step 8. With D as center and same radius, draw an arc in interior of angle DOC that cuts the previous arc at E. Step 9. Join OE. Angle AOE is the required angle.